Okay, hi guys. So I'm going to go through some questions in preparation for your UCAS exam coming up tomorrow. The first question is on circles, so coordinate geometry. It says a circle has a center 6, 4, and the radius is 3. Write down the equation of the circle in the form. So this one here should be nice and easy 2 marks. You just need to write out the equation of the circle. So actually a GCSE question. Okay, so it's going to be x minus 6. Okay, I might just erase that so it's clear. X minus 6 squared plus y minus 4 squared. The radius is 3, so it's going to be 9, 3 squared. Okay, so that's the equation for my circle. The next part says the diagram above shows a circle C. The point T lies on the circle and the tangent at T passes through the point P, which is 12, 6. The line M to P cuts the circle at Q. Now, you know from GCSE circle theorems that the tangent to the circle always cuts at 90 degrees. Okay? All right. It says show that the angle TMQ is 1.0766 radians to 4 decimal places. Now we haven't covered radians. I'm just going to cross that out and I'm just going to write this in degrees. So in degrees, this is 61 point, let's say 61.68 degrees. Okay. So we'll cover radians next year. But for the purpose of this question, let's just say that's 61.68. So we need to prove that this angle here is 61.68, okay? Now I can see already that I can do that quite easily by using SOHCAHTOA. I have the adjacent here. I would just need to work out the hypotenuse. To do that, I need to work out the distance from P to M, which again is a GCSE question. Is to work out the distance, you're just going to use Pythagoras. So you're going to find the difference between your X values and your Y values. So we've got 12 take away 6, 6 squared, 6 take away 4, 2 squared, and then we apply Pythagoras and get 2 root 10. So this length here, M to P, is 2 root 10. Okay, now we're ready to use Pythagoras. Okay, so I'm just going to write it over here actually. So you've got cos theta, so I'm just going to call this theta, is equal to the adjacent, which is 3, over the hypotenuse, which is 2 root 10. So inverse cos 3 over 2 root 10, which you can do into your calculator, is 61.68 degrees as required. Okay, and that's your 4 marks. All right, moving on. So the next part says the shaded region TPQ is bounded by a straight line T to P and Q to P and the arc T to Q, as shown in the diagram above. Find the area of the shaded region TPQ and give your answer to 3 decimal places. Okay, so what we're going to need to do, and you need to think about what your strategy will be. Okay. So I can see, to me, the easiest thing to do is to find the area of this whole triangle and then just subtract the area of this sector. So to work out the area of the whole triangle, I can use half AB sine C. And then I can subtract the area of this sector, which I know is just theta over 360, and I put some brackets here, times by pi r squared. Okay, so I'm just writing out my formula so that you can see what I'm doing. Okay, so we know this length here, M to P, is 2 root 10. We know what the angle is, so I'm just going to write this here. Theta was 61.68. Okay, so we've got a half times 3 times 2 root 10 times by, oops, that looks like 0, so it's a 10. Times by sine theta, which is 61.68. Plug that into my calculator, and then I'm going to subtract 61.68 over 360 times pi times 9. Okay. So this here will give me approximately 8.3517. This part here will give me about 4.8446, leaving my answer as 3.5. They want it to 3 decimal places. Okay, 0.7. Okay, so 3 decimal places. And that is my answer. Okay, it's an area, so I need some units, don't I? Okay, I think I can just write units squared. Okay, because they didn't actually give us any units here. Right, so moving on to the next question. Okay, so another coordinate geometry question. We've got the points P, which is -3, 2, and the point Q, which is 9, 10. And then we have point R, which is A and 4, so we have an unknown here. Lie on the circle C as shown in the diagram above. Given that P to R is a diameter of C, show that A is equal to 13. Okay, so again, they are drawing on your GCSE knowledge of circle theorems here. There is more than one way of approaching this question, but I always try to look for the easiest method. The easiest method I can see is that this is a right-angled triangle, and I know for sure it is because one of its sides happens to be the diameter of that circle, because we're told this in the question. We said that P to R is the diameter. So if one of those sides is the diameter, then this is definitely a right-angled triangle. Okay, so you would have learnt that in one of your circle theorems that you did at GCSE. So this is 90 degrees. The angle at which the right angle within a semicircle meets the circumference is 90 degrees. So that therefore means that P to Q bisects Q to R. Okay, it's the perpendicular bisector. And it means that the gradient of P to Q is going to be the negative reciprocal of the gradient of Q to R. So what I'm going to do is I'm going to find the gradient of P to Q. Okay, so that's just going to be 10, take away 2, so change in Y over change in X, so 9 minus -3, and that gives me 2/3, okay? Then I know that because this is definitely a right-angled triangle, and one of those sides happens to be the diameter of that circle, then I can say that this gradient here, the gradient of this line here, is going to be the negative reciprocal of P, the gradient of P to Q. So it's going to be -3 over 2. Okay, so the gradient, I'm going to say, I should have really written. Okay, so the gradient of Q to R is going to be -3 over 2, but let's write this involving A. So it's going to be 10 take away 4 over 9 take away A. And I'm just going to rub this out and just write it a little bit lower so you can see -3 over 2. Okay, so this is 6 multiplied out by 2, that gives me 12. Take that over to the other side. So I get -27 and then +3A. That therefore gives me 39 is equal to 3A. Therefore, A is equal to 13 as required. Okay. Part B is asking you to find the equation of C. Okay, so we're going to need to do a little bit of work here. So the first bit is that we know that A is equal to 13. So even if you didn't know how to work out part A, you would still know that the coordinate of r is 13, 4, okay? Because it was a pre question. I'm just going to clear my working out, and I'm just going to, just to make a bit more space here, that's 13, 4, okay? Now, to work out the equation, we need the center and we need the radius, okay? So we already have here, we already know this is diameter, we already know these 2 points here. What we could do is to work out the center is just find the midpoint of this line. So you add your x coordinates together, so 13 plus, let me do this over here, so you've got 13 plus -3, okay? And then you have, you need to divide that by 2. And then you have 4 plus 2, which is 6, divide that by 2. So here we've got 10 over 2, which is 5, 6 over 2, which is 3. So our center is 5, 3, okay? That's the coordinate. So we know already my equation starts off like this, x minus 5 squared plus y minus 3 squared. Now we're missing our radius, okay? Different ways we can approach this. I'm going to go for the easiest, which is I'm going to use Pythagoras to work out what our radius r is, okay? So to get from -3 to 5, that's 8 units across in the x direction. And then to get from 2 to 3, that's 1 unit up in the y direction. So using Pythagoras, you've got 8 squared plus 1 squared, which is just root 65, okay? So we know that our radius is our radius is root 65. So radius squared is just 60, our radius squared is 65. Right, next question. So here we have a nice, easy transformation problem. It says the diagram shows the graph of y equals f of x. The point P21 lies on the curve. So we know that if they give you the point 21, that we need to be very clear that when we draw the graph of this transformation, that we are ensuring that we include our new coordinate for point P. We don't know where the y-intercept is because we don't actually know what the real equation of this graph is. We just know it's a function. Okay? So on your new graphs, you need to make sure that you've got the y and x axes clearly labeled, your origin is labeled, and most importantly, your point P is labeled, or your new point P is labeled. Sketch on separate diagrams the following graphs. On each graph, label the image of the point P giving its coordinates. Okay, so first one. Okay, so I've just drawn this over here. Okay, as you can see, my new point is at 2 minus 1. And what's actually happened is that this transformation here, where you've got negative f of x, has meant that you needed to reflect the line in the x-axis. Now remember at GCSE, you know that when there is a change on the outside of your bracket, that it's going to affect your y coordinates, okay? That means all of your y coordinates are going to be multiplied by -1. So here you can see your point P, your y coordinate has been multiplied by -1, which in other words means that it's a reflection in the x-axis. So for the next one, I'm just going to clear my screen. So for the next one, as you can see, there's two things going on here. You've got f of x plus 3, so you've got something going on inside your brackets, and then you've got something going on outside your brackets. Remember, when there is a change on the inside of the bracket, it's affecting your x values. When there's a change on the outside, it's affecting your y brackets, your y values. So it's always best to start on the inside and deal with what's going on in the brackets first, and then work your way out. So you complete the first transformation, which is x plus 3. So instead of adding 3 units to the right, you always do the opposite. So you're going 3 units to the left, okay? So it's only affecting your x coordinates. So remember, anything that's going on in the inside of your brackets here is affecting your x values. So you've got 2 units here. You're going to move 3 units to the left. So your p-value is now going to be at -1, 1. Nothing's happened to my y value. It stayed the same, okay? So you've literally just picked up the graph and moved it 3 units to the left. Now what you've got to do is sort the 2 out on the outside, which affects your y coordinate. It's a stretch. So you have to multiply your y value by 2. So that means it's going to stretch upwards. So your new coordinate is going to be at -1, 2, which is up here. Okay, so all you've got to do is just draw that on. This is my f of x. And you should get the point so long as you've written down -1, 2. Okay. Next part of the question says, the graph of y equals 2 of f of x plus 3 is obtained from the graph of y equals f of x by a sequence of 2 geometrical transformations. Describe each of these transformations fully. That's an easy 2 marks. So the first one was a shift of 3 units to the left. Okay, so you're moving the graph 3 units to the left. And then the next is a stretch of 2 units in the y direction. Okay. Right. So next question. We've got a logs problem. Given that x is less than 4 but greater than 0, and log base 5 of 4 minus x minus 2 log base 5x is equal to 1, find the value of x. Just to be clear, from the previous question, I think I may have said you're moving it up by 2 units. You're not. It's a stretch of a scale factor of 2. So you're multiplying all your y's by 2. I just wanted to make that clear just in case. Yeah. So next problem. So you've got the logs problem. So let's have a go at this one. You need to use the laws of logarithms. I'm going to rearrange this. I'm going to take this 2 and bring it over so it's x squared. So log base 5, 4 minus x minus log base 5 x squared equals 1. And you'll see why I've done this in a second. Remember, when you're subtracting, this is the same as saying log base 5, and it's 4 minus x over x squared is equal to 1. That therefore means that 5 to the power of 1 is equal to 4 minus x over x squared. Let's multiply out, so you get 5x squared is equal to 4 minus x, which is 5x squared plus x equals 4. Oh, silly me, minus 4 equals 0. So let's factorize. So you've got 5x minus 4 and then x plus 1. So your solutions are x can equal -1 or x can equal 4 over 5. However, they did say that the value of x has to be less than 4 but greater than 0, so it's definitely not -1. So our value for x is 4 over 5. That was a nice, easy question. Okay. So an easy 6 marks, to be honest. Right. Okay, so now we have another logs problem. Given that log base 5x is equal to a and log base 5y is equal to b, find in terms of a and b the following. Okay. So let's see what we can do with the first one. I'm going to write this out a little bit differently. So I'm going to say this is equal to log base 5 of x squared minus log base 5y, because you're dividing here, so we can write this out using the laws of logarithms. I'm going to take the 2 over. So it's log base 5x minus log base 5y. That gives me, well, I know that log base 5x is a, that's 2a minus b. because when you look at this, it actually simplifies quite nicely. Okay. The next part is, okay, let's see what we can do. So I'm gonna, can already spot you've got log base 525. Now we're multiplying here, so I'm going to split these up. Log base 5x plus log base 5 of y to the power of a half. It's the square root of x, square root of y, so it's just y to the power of a half. Let's take that y over, take the half over. Okay, so this here is just 5, because 5 squared is 25, so we know it's 5 to the power of 2, so it's 2. This here is a, and that's a half, and this bit here is b, and that's your answer to part B. Okay. Right, next question. Use proof by contradiction to prove that each of the following statements. If n cubed is odd and n is a positive integer, then n is odd. Okay. So these aren't really popular amongst year 12s. They always struggle with the proof questions, but once you've practiced, they are really quite straightforward. So let's do part A. So it says use proof by contradiction to prove each of the following statements. If n cubed is odd, where n is a positive integer, then n must be odd. Okay, so then assume, so you need to first write down your statement, your combo statement, which is assume that n cubed is odd, but n is even. Okay, so you just, this is literally me starting to prove by contradiction. Okay, where n is an element of the positive integers. Okay, so let's say n is even. Therefore, that then means that n is equal to 2m. M is an element of the integers. Okay, that means n cubed is equal to 2m cubed, which is 8m cubed, which is 2 bracket 4n cubed if we factorize it, which is even. Okay, so this is even, therefore it's a contradiction, and it means that n has to be odd. Okay, so this is a contradiction. So we can say, just to finish, n cubed, an element of the integers, therefore n cubed is even. So it's a contradiction. Therefore n is odd. Okay. Part B is actually an A2 proof question, so I'm going to leave that one out because you're not going to get that for AS. This will be pure 2. Will be in a next year's content. Okay, please do let me know if you have any questions.